Hi girls, in this video we're going to be going through how to figure out the degree of hydration and what that means. So a lot of the time our compounds, particularly ionic compounds, like to absorb water. So you can see here in the picture that we have what we call hydrated copper sulfate over on the left, and that means that it's copper sulfate, but there's about 5 water molecules that are bound to each one of the copper sulfate ones on average throughout that, and it appears to be blue. If you were to completely dehydrate that, say in an oven, you would become anhydrous, an meaning without, and hydrous meaning hydration or water. So what we've got here is anhydrous copper sulfate plus 5 molecules of water would go somewhere else in the oven. But the thing is, a lot of the time we don't buy compounds and we don't make compounds and they don't come in a format that's not the hydrated version of them. So before we go on to the example, I'm just going to show you really quickly the notes so that we're aware of where we're going here. It's just going to be funny and not let me move. That's helpful. So what it says at the top there, it's a bit hard to see. It says a hydrated salt is an ionic compound that contains a certain proportion of water molecules in its solid crystals. So that's the first sentence. These water molecules are attracted to and surround the ions in the solid crystals. The degree of hydration of a hydrated salt, and here we are, we're finally there, is a measure, oh no, it's not going to let me highlight, measure of the proportion of water present. It is the number of water molecules present for each formula unit. So that's what I was just saying before. It's how much water there is compared to how much chemical substance. For example, copper 2 sulfate pentahydrate, penta meaning 5, CuSO4.5H2 is said to have a degree of hydration of 5. Now, the reason that we introduce this is because this is calculated in the same way that we do an empirical formula calculation. And that's why I've come back to here. So when we come back to here and we determine the empirical formula and hydration of the following salt. It's a 10-gram sample of the hydrated BaCl, and it contains 5.2 grams of barium and 2.87 grams of chlorine. So let's just write that out so we know what we're talking about here. So we're going to have barium, yes, we're going to have chlorine, and we're going to have water, and we're going to keep them together as water. We're not going to split them as hydrogen and oxygen because we don't know what our ratio is there, but the question has given us enough information to figure out the mass of the water. So by mass, they've told us that we've got 5.62 grams of barium. We've got 2.87 grams of chlorine, and altogether it has to add up to 10. So when you do this, that's 10 minus 5.62 and minus 2.87, and you end up with 1.51. Okay, so that's how I've got that number there. So here are my 3 masses. So this is where we go mass. The next part we need to do is the mole. So how do we get to the mole? We've got to divide by my MR of each one of these. So when you look at the periodic table, you can see that barium is 137.3. You can see that chlorine is 35.5, and H2O is 2 times 1 plus 16, yeah, which means that it's equal to 18 on there. When you plug that all into your calculator, and I expect you to be pausing if you need to and putting these numbers into your calculator, what you end up with is your ratio. So your ratio is going to be 0.0409 to 0.0808 to 0.0839. Okay, you're going to divide them by your smallest. Which one is the smallest? It's the first one. Divide them all by 0.409, 0.0409. And what you end up with is a ratio of 1 to approximately 2 to approximately 2. And so therefore, what our ratio here, this is where it gets a little bit tricky, is we've got BA. Oh, sorry, girls, I'm just going to. Oh. So our ratio is 1 to 2 to 2 of BA, chlorine, and water. Now we know that we have to have something with a dot and then the water after it, and we're going to have BaCl, but we need to figure out what our coefficients are. So this one is going to have 1 down the bottom, so I'm going to leave that blank. So barium's going to have 1, chlorine's going to have 2, and we're going to have 2 H2O. And that big 2 goes in front because it means we need 2 water molecules.